Hi, Algebra 2. We are about to make a journey into graphs of trigonometric functions. And so we're going to start looking at what would the sine function and what would the cosine function look like if we graphed them. But before we get to that, we'll do that later in the week, we need to talk about a more general type of function, and that is a periodic function. And so the definition of a periodic function is a function that repeats a pattern of y values. So the outputs repeat themselves again and again and again at a regular interval over the same amount of time or same amount of x values in the domain. And so you can see this is an example of a periodic function. You can see that it's going through the same y values. It is increasing to a height of 2, decreasing to a height of -1 over the same amount of x values. And it's as if you can take one piece of that function, cut it out and lift it up and slide it horizontally, and it will overlap the next piece of the function, and the next piece, and the next piece, and the next piece. And so there is a pattern that repeats itself again and again. One complete pattern is called a cycle, and there is no set beginning to any cycle. But once you choose a beginning point, there is a definite ending to that one cycle. It's when the function begins to repeat itself again and again. So you can see here's an example, this red piece of one cycle. We started at what we call the maximum, the highest height, at 2, and we decreased, went down, and then we went back up. And then notice at this point, this is the end of the cycle because we're going to begin that pattern again, down and up, down and up. And so each of those is one cycle. But we didn't have to start at a maximum. Here we started at a 0 where the function actually has a y value of 0. And it went up, increased, decreased down to the minimum, and back to 0. Notice it hit 0 here as well, but that's not the end of the cycle because we have more of the pattern to complete. So here would also be one cycle. We could have looked at one cycle being from a minimum up to that maximum, back to a minimum again. This would be one cycle. And no matter where you start a cycle, it will always be the same length in that periodic function. And we call that length one period, or the period length is the length of one cycle. So I can see here I began at an x value of 2 and it was completed at an x value of 6. So to get from 2 to 6, that has a period length of 4. You can also see that over here. Here it started at 8. This would be the x value of 8 all the way to an x value of 12. That was one cycle, different looking piece, but completes the pattern. And from 8 to 12, that's also 4. And that's the same thing between every two minimums, -1, 2, 3. That is a distance of 4. So a periodic function repeats itself over the same y values, and the length of that pattern is the period length, and that occurs over a single cycle. There's also one other word that we want to define, a way to describe a periodic function, and that is amplitude. Those of you who have been in physics have probably studied some waves. Maybe you got to those this year. And amplitude would be a term that you'd be familiar with. Here you can see this is a periodic function. It actually looks like molars' teeth to me, right? And there's the little grooves. If you don't brush, you get a cavity right in there. But we are going up. And if we look here, I could see one cycle from minimum to minimum. That cycle length would be 6, right? Or I could do from this first cap to the first gap, that would also be 1 cycle. And from 2 to 8 is 6. So that is the period length is 6, the length of 1 cycle. But the amplitude of a periodic function describes its stretch. How tall is it? And really, it's height from a midline. You can see here, this line right here is drawn in the middle of the function. That doesn't mean its area is the same above and below, because it looks like it's bulkier up here than it is below. But if we look at the maximum value would be 3, minimum value, -1. That midline's halfway in between those. And I like to draw in that midline. I think it's a good visual. The amplitude is the stretch from the midline. So wherever the vertical middle of that periodic function is, how much you have to stretch to the maximum is the amplitude. That's also how much you have to stretch to go down to the minimum. So I can look here and go, oh, that amplitude is 2. I'm stretching from a height of 1 up to 3. That amplitude is 2. Now, when you have a graph, I like to draw the midline and visualize it. Do be careful of the scaling on your y-axis. If it's going by 5s, don't just count squares. That's not going to give you a correct amplitude. But if you're just told what the minimum and the maximum value is, there's a nice formula for amplitude. It is the maximum value minus the minimum value cut in half. And you can see visually how that maximum minus the minimum, that would be 3, subtract -1 would be 4, and half of 4 is 2. That would be that stretch. So today we're going to be looking at functions, determining are they periodic? If they are, because cycle, period length, amplitude don't have anything to do with functions if they're not periodic. So if the function is periodic, then we will go ahead and find the cycle length, the period length, and the amplitude. So let's take a look at some examples. The first thing we need to decide is this periodic? Is there a repetition in just the y values? Are we going up to the same height each time over the same amount of distance? And from here, notice it swoops down, comes up a little, all the way down and back. And then it swoops down, comes up, all the way down and back. This function is in fact periodic. When you do that, and I'd like to see this in your homework as well, highlight 1 cycle. It's going to be helpful, and it lets me know if you are identifying those correctly. It doesn't have to be exactly what I highlight when you see my answer key. You could begin from a maximum here, come down, and then you have to make it back up to that point. There's 1 cycle. But you could have started the cycle here at the little mid relative maximum and come through there. That could have been the cycle as well. So this is in fact periodic. There is 1 highlighted cycle. Let's determine the period length. How long is that cycle? Here is 3 to 7. So that function has a period length of 4. Now let's find its amplitude. So amplitude we can do visually, or we can use that formula. Let's try that little formula. Half of the maximum, let's see what the maximum is, 5, minus the minimum 0. So 5 minus 0 is 5. Half of that is 2.5. So the amplitude is 2.5. If I look here and try to draw the midline, I'm going from 0 to 5, that midline would be right there. I'm looking, how much am I stretching above and below that line? Well, you can see I'm stretching 2.5 in either direction. All right. Okay, let's look at this example. Is this periodic? At first glance, it begins to look periodic. We are waving up and down and up and down and up and down. But on closer examination, notice that this wave is just a little fatter. Here from these 2 points, they're a distance of 2, but over here, those midpoints, that's only 1.5, so this is not periodic. And so we're not going to find an amplitude or a period length for that because it's not periodic. All right, this one here, yes, it is in fact periodic. It repeats itself over the same y values. You can just shift it to the left or right and it will repeat itself. If I want to look for one cycle length, that would be one cycle. And how long is that? Now, look at here. I chose kind of some bad points to begin and end my cycle if I want to figure out the cycle length. Maybe I would do better. I don't know that point exactly. I don't know that point exactly. I don't know that one, but I do know here. That's at 0, and over here it would be at 1, 2, 3, 4, 5. So sometimes what you highlight isn't the most helpful, like I just did there, and you might want to look at another piece. Or sometimes you even look at, ooh, I can tell the exact length of 3 cycles, so find that length and then divide by 3 to find the length of 1 cycle. All right, and the amplitude. I am stretching from -1 to 2. So 1/2 of maximum of 2, subtract -1. Make sure you subtract the negative because it actually is a total distance. That's what that maximum minus minimum does. It gives you the total distance. That's 3. And then we need to divide that by 2. So that amplitude is 1.5. All right, a couple more examples. Is this periodic? Well, it has a definite pattern, and I could continue that graph. But notice it's not enough to just have a pattern. Are we covering the exact same y values? Well, no, the y values keep going higher and lower. And so while this has a pattern, this is not periodic. Okay. Here's a nice wave. The waves have the same distance between them each time. They are covering the same vertical distance. So yes, this is periodic. And I'm going to highlight 1 cycle. That would be 1 cycle right there. What's the length of that cycle? It is 1, 2, 3. So the period length is 3. The amplitude, if I just do this in a visual way, I'm going to look for half. Here we've covered 1, 2, 3, 4 squares. So my midline would go halfway in between. And it's the stretch from the midline up. It's 2 squares. Make sure you know the units on each square. It looks like 1. So the amplitude is 2. We are stretching down 2 from the midline and up 2 from the midline. All right, last example. Is this periodic? It is. We've got the same pattern repeating itself. Little, big, little, big, little, big. These are like a nice mountain range there. It is periodic. What is the length of 1 cycle? That goes from 2 to 5. So the period length is 3. And the amplitude, I'm going to cut this in half from the maximum to the minimum. And notice the graph is stretching one above that midline and one below that midline, so the amplitude is 1. All right. So we know now that a periodic function repeats itself over the same y values over the same length of x values. And we can identify one cycle. The length of that cycle is the period length. And the amplitude is the stretch above or below the midline. And we can determine that by 1/2 of the maximum minus the minimum. All right. Good luck. Email me any questions and we'll talk to you again soon.